This problem is a motion problem. It states that the current in a stream moves at a speed of 2 kilometers per hour. A boat travels 44 kilometers upstream and 52 kilometers downstream in a total of 4 hours. What is the speed of the boat in still water? Our first step will be to familiarize ourselves with the problem. That could involve rereading it. And whenever we have a motion problem, we're looking at 3 quantities: distance, speed, and time. So let's look at the problem before we write anything down and see what we know about the distance. We notice that the boat travels 44 kilometers upstream and 52 kilometers downstream. The distances are different for both of those, but they're given. The time we see is a total. We don't know how much time was traveled upstream or downstream, but those times should add to 4 hours. And as far as speed goes, we're given the speed of the current and we're asked to find the speed of the boat. So we're going to have to know how the speed of the boat with the current and against the current will be, how that will work together. So when we move to our familiarize step, we'll begin writing by assigning a variable. We're asked to find the speed of the boat in still water. So let's let that be r. And I'm going to spell out exactly what I'm looking for, what I'm letting it equal. R is the speed of the boat in still water. And then what will the speed be going with the current? Well, with the current will push the boat along. The speeds are actually added. With the current, the speed will be r plus 2, and that would be downstream. And then against the current, the speed would be r minus 2. That's the speed of the boat minus the speed of the current, and that would be going upstream. Now, whenever we have a motion problem, we should organize our information in a table. The columns of the table can be distance, speed, and time. And the rows can be the different motion situations we're looking at. In this case, we can call them upstream and downstream. And that gives us 2 rows to fill out and 3 columns in each row. And what I like to do is fill in the numbers that I know to start with. I know the distance upstream, and I might need to look back at the problem. 44 kilometers upstream, 52 kilometers downstream. So I can fill this in with 44 and 52. Now, I've also, in my familiarize step, realized or worked out that the speed with the current downstream was r plus 2, and the speed upstream was r minus 2. I don't know the times. At this point, I'm just going to label them t, and I'm going to use some subscripts because I want to make sure they're both times. And I'm going to call one t sub 1, that means time 1, and t sub 2, time 2. And I remember that these times are a total of 4 hours. Well, I can move to the translate step next. And in the translate step, I'm going to use the equation distance equals rate times time, or I'm going to use actually time equals distance divided by rate, because I'm going to want to add the times together to get 4 hours. So my next step will be to translate. And I translate each row of the table. The first time, I'm going to use time equals distance divided by the rate or the speed. The first time, or the time upstream, is the distance upstream divided by the rate upstream. The second time, the time downstream, is the distance downstream divided by the speed or the rate downstream. Now, the key to the translation is that these times add to 4 hours. So I can write 44 over r minus 2 plus 52 over r plus 2 equals 4. When I've done this, I now have an equation with just one variable, r, and I can solve that for r. When I solve an equation like this with a variable in the denominator, I want to multiply by the least common multiple of the denominators. In this case, the least common multiple is r minus 2 times r plus 2. So I'll multiply both sides of the equation by this quantity. I write r minus 2 times r plus 2, and then I'm going to write a big parenthesis, and I'm going to copy the entire left side of the equation. 44 over r minus 2 plus 52 over r plus 2. And now I have to multiply the other side by the same amount. R minus 2 times r plus 2 times 4. Now in this next step, when I actually do the multiplication, the denominators should be cleared, that's why I multiply by this least common multiple of the denominators. I multiply r minus 2 times r plus 2 times 44 over r minus 2. What that looks like is this: r minus 2, r plus 2, 44 over r minus 2, plus, and then it would be r minus 2, r plus 2, 52 over r plus 2. And that equals this product, and I'll simplify it a little bit by multiplying r minus 2 times r plus 2, which is r squared minus 4 times 4. Now looking at this, I can cancel the r plus 2 in the numerator, which is a factor, with the r minus 2 here in the numerator, with the r minus 2 in the denominator. I'm actually left with a denominator of 1. Over here, I can cancel the r plus 2 factor in the numerator with the r plus 2 in the denominator. And again, though I don't have to write it, I'm left with a denominator of 1. Now when I write this, I have 44 times r plus 2 plus 52 times r minus 2 equals, I'm going to write this as 4r squared minus 16. Now I have nothing in the denominator. They're cleared. So I continue solving. Multiplying, I have 44r plus 88 plus 52r minus 104 equals 4r squared minus 16. And then I can combine like terms. 44 plus 52 is 96r. 44r plus 52r is 96r. 88 minus 104 would be minus 16, and that equals 4r squared minus 16. And I can see that I have a quadratic equation here, and I'll do one more step on this page and then go to another page. I'll add 16 to both sides, and that gives me 96r equals 4r squared. Now to solve 96r equals 4r squared, I'll subtract 96r on both sides, which gives me 0 equals 4r squared minus 96r. Notice that I don't try to divide by r here. Since it's a quadratic equation, I want to get a 0 on one side, and then I can factor. And I factor out a 4r, and I get 4r times r minus 24. Now I have a product. 4r times r minus 24 equals 0. So I can set each factor equal to 0. 4r equals 0, or r minus 24 equals 0. Solving those separately, I get r equals 0 here, and r equals 24 here. So I have two possible solutions, and I'm ready for step 4, which is to check the answer in the original problem. Let's go back to the original problem, and see if we first of all have found what we were looking for. We're asked to find the speed of the boat in still water, and that was what we defined r to be. Now let's see if either of those makes sense before we check the numbers. Does it make sense to have the speed of the boat in still water to be 0? Well, if the speed of the boat in still water was 0 and we had a current, it couldn't go upstream at all. So r equals 0 is not a possibility. So let's check r equals 24. If the speed of the boat in still water is 24, then the speed upstream would be 24 minus 2, or 22 kilometers per hour. And the speed downstream would be 24 plus 2, or 26 kilometers per hour. Now we know that the distance upstream was 44 kilometers. The distance downstream was 52 kilometers. How long did it take to travel? Well, the time upstream would be the distance divided by the rate, or 44 divided by 22, which would be 2 hours. The time downstream would be the distance downstream, which was 52 kilometers, divided by 26 kilometers per hour, which would give us 2 hours. The last thing we're told in the problem, the last piece of information, is that the total time was 4 hours. And since 2 plus 2 is 4, we do have a check. And we can state our answer, and that is that the speed of the boat in still water is 24 kilometers per hour.